Today we are going to start with your exercise 12.1. Question number 1 says maximize z is equal to 3x plus 4y subject to constraints x plus y less than equal to 4, x greater than equal to 0 and y greater than equal to 0. Let us start with the solution. Here the objective function is your z is equal to 3x plus 4y and it needs to be maximized. Okay, and non-negative constraints are x greater than equal to 0 and y greater than equal to 0. Okay, what does it mean? It means that solution will be lying only in the first quadrant. So for plotting the graph, first of all, let's consider the corresponding equation of your given inequation. X plus y less than equal to 4. What is the corresponding equation? X plus y equal to 4. Okay, so for plotting, let's see y is equal to 4 minus x. Then we will take a table and that xy, just two values are sufficient where it is touching the your coordinate axis. For it, you will put once x0, you will get y4 and y0, x is 4. And next thing is to check the origin. So checking of the origin will be done from the inequation. So how will you check? You will put both x and y 0 in the inequation x plus y less than equal to 4. That is 0 less than equal to 4. Is it true? Yes, it is true. So what does it mean? It means that origin is satisfied. And it concludes that shading will be towards the origin. Okay, shading will be towards the origin. So let us see the graph of this your corresponding inequation. That is your x plus y less than equal to 4. Only one line is there and area lying in the first quadrant is to be taken. And since the shading is towards the origin, so the area towards this shaded portion will be this, and in the first quadrant will give you this triangular portion. And what are the corner points? 3 corner points are there. One is 0, 0, other is 0, 4 and next one is your 4, 0. So 3 corner points here are given. Now let us apply the corner point method. Corner point method says evaluate your objective function z is equal to 3x plus 4y at these corner points. So let us frame a table. Corner points, this is your objective function and these are your 3 corner points 0, 0, 4, 0, 0, 4. And get the value of this objective function. It comes 0, it comes as 4 3s are 12 and it comes as 4 4s are 16. And you know, since the curve is bounded in this question, so when the curve is bounded, you will get both maximum and minimum value here. Okay, so you need to just find out the maximum value. So z is equal to 16 is the required maximum value. So the objective function is maximum at b is 0, 4 and the maximum value is z is equal to 16, which is occurring at x is equal to 0 and y is equal to 4. Now let us see your question number 2. In this question, you need to minimize z is equal to minus 3x plus 4y subject to x plus 2y less than equal to 8 and 3x plus 2y less than equal to 12 and x greater than equal to 0, y greater than equal to 0. Okay. So again, let us start the solution. Here objective function is z is equal to minus 3x plus 4y and it needs to be minimized. And x greater than equal to 0, y greater than equal to 0 means the non-negative constraints, which gives you area only in the first quadrant. And given inequations are your x plus 2y less than equal to 8, 3x plus 2y less than equal to 12 and this you are clear what we are talking about. So consider their corresponding equation. X plus 2y is equal to 8, 3x plus 2y equal to 12. Prepare the table. Y is equal to 8 minus x by 2, just two values. When x is 0, y comes out to be 4 and when y is 0, x comes out to be 8. And then we will check origin here, that how origin is behaving. So you will put x0 and y0 in your equation and you will get 0 less than equal to 8. Is it true? Yes, it is true. So that means shading will be towards the origin. In the second inequation, 3x plus 2y is equal to 12. Y is equal to 12 minus 3x divided by 2. Okay, so the table, just two values. When x is 0, y is 6. When y is 0, x is your 4. And let us check the origin. Checking of origin gives you 0 plus 0 less than equal to 12. That is 0 less than equal to 12. Is it true? Yes, it is true. So that means shading will be towards the origin. That means this time also we are going to get a bounded curve. So let us see the graph of this question, and the graph of this question is like this. Okay. Now this is the plotting of line 3x plus 2y less than equal to 12. Since the shading is towards origin, so means you have to shade the area this way. Okay. This is x plus 2y less than equal to 8. Again, shading is towards origin. So you have to take this way. Okay. And the common shaded portion will be given by this quadrilateral, that is 0, A, B and C. The curve is bounded curve again. Okay. So 4 corner points we are getting for this question. Let us apply the corner point method. Let us see what are the corner points. 0, 0, 0, 4. This is 2, 3 and this is 4, 0. Since you will plot it on graph paper, so you will be able to locate your this B, 2, 3. Otherwise, this point can also be calculated by solving pair of these two linear equations. Okay. But since the plotting is done on graph, so you will be able to locate it from the graph itself that B is coming out to be 2, 3. Now let us apply the corner point method for this objective function z is equal to minus 3x plus 4y. So 4 corner points when checked, you will get for 0, 0, z0. For 0, 4, you will get z as 16. For 2, 3, you will get z as 6. And for this 4, 0, you will get the value z is equal to minus 12. So again, the curve was bounded. So bounded curve, we get both maximum and minimum values. But we just need to minimize the objective function. So what is the minimum value? Z is equal to minus 12. Here is the minimum value. And it is occurring at x is equal to 4 and y is equal to 0. Let us see your question number 3. You need to maximize z is equal to 5x plus 3y subject to 3x plus 5y less than equal to 15. Okay. So the equation in equation 2 in equation are given here are 3x plus 5y less than equal to 15, 5x plus 2y less than equal to 10 and x greater than equal to 0, y greater than equal to 0. Okay. They are non-negative constraints. Again, area lying in the first quadrant itself. So given constraints are number 1, number 2. Okay. Now corresponding equations you have to consider. 3x plus 5y equal to 15. Y is 15 minus 3x by 5. You will prepare the table. When x is 0, y is 3. And when y is 0, x is 5. Okay. And let us check the origin in the inequation itself. Here in the inequation, 0 plus 0 less than equal to 15. 0 less than equal to 15. Origin is satisfied. So that means shading is towards the origin. Again, for this second part, y is equal to 10 minus 5x by 2. You can find out any or y equal to or x equal to, just I need two values. When x is 0, what is the value of y, and y is 0, what is the value of x? That means I need to locate where it is touching your coordinate axis. Okay. So I get 2 points 2, 0 and 0, 5 here. Okay. Let us check the origin in the inequation. 0 plus 0 less than equal to 10. So 0 less than equal to 10. That means again your curve is having shading towards your origin. Okay, as origin is satisfied. Now let us see the graph of this. This is your line 5x plus 2y less than equal to 10. Shading is towards origin, so this side. Okay, as I just have put arrows to tell you the direction. Okay, in the other one 3x plus 5y less than equal to 15. Now shading is towards origin, so this way. And the common area will be again the quadrilateral 0, A, B, C. Okay, so how many corner points? 4 corner points. One is your 0, 0, other is your 0, 3. This is by point of intersection you can locate. And this point is turning out to be 20 by 19 and 45 by 19. Okay, you can solve both the equations or graphically also you will be able to locate. But in such fractional questions, you just need to, it's better you solve both the equations, linear equations like 3x plus 5y equal to 15 and your 5x plus 2y equal to 10. Okay, by just making the two coefficients equal, you will be able to get the values of x and y. So here I got the value as 20 by 19 and 45 by 19. Okay, so let us check the corner points, applying corner point method for these 4 points. And the value of the objective function for 0, 0 is 0. For 0, 3 it is 9. For B, 20 by 19, 45 by 19. This is turning out to be 235 by 19. And for 2, 0 it is turning out to be 10. And I can locate out of these, this is the maximum value which is my required maximum. So Z is maximum at x is equal to 20 by 19 and y is equal to 45 by 19, and maximum value is your 235 by 19. Z is equal to 3x plus 5y such that x plus 3y greater than equal to 3, x plus y greater than equal to 2, and xy greater than equal to 0. Okay. So one thing from these two inequations we can judge, as the inequation are involving both signs as greater than equal to, that means this feasible region is going to be unbounded one. Okay. So let us see. Given constraints are your x plus 3y greater than equal to 3 and x plus y greater than equal to 2, and xy positive, they mean area lying in the first quadrant. Okay. Corresponding equations are x plus 3y is equal to 3, y is equal to 3 minus x by 3. Just two values we require. Once x is 0, y is 1, y is 0, x is 3. Okay. Check origin itself in your inequation. So put x and y both 0 in this inequation. So we get 0 plus 0 greater than equal to 3. Is 0 greater than equal to 3? No, it is not true. So it is false. What does it mean? It means that I have to shade the region which is not towards origin. Okay. That is, shading is away from the origin. For the second inequation, the corresponding equation is x plus y is equal to 2. Y is 2 minus x. So xy is your x0, y2, y0, x2. Checking of the origin. In this inequation, 0 plus 0 greater than equal to 2. Is it true? No, it is not true. It is false. So origin is not satisfying. So again, shading is away from the origin. Okay. Now, see the graph. See the graph of this question. This graph is, this is your inequation x plus y greater than equal to 2. Okay. These points 0, 2 and this point 2, 0 is plotted here. This is the line. Okay. And again, since the sign is of greater than equal to, so I have taken this complete line as complete one. Okay. Otherwise, if it is strict sign, we need to take it as dotted line. Okay. For the second one, x plus 3y greater than equal to 3. This is the line which is plotted. Okay. So see for this, as shading will be away from the origin. So it is not towards this side. It is towards this side. Okay. And for this side line, shading is again away from the origin. And x positive, y positive means area in the first quadrant. So see, just concentrate. What will be the area? See, this is the portion of first line. Okay. I cannot take this as it is not included in the second equation. So see, from the first line this part, from the second line this part. Okay. And all the area in the first quadrant and your including these both portions of the line, the area, this area is the required shaded portion or feasible region, and it is an unbounded feasible region. Okay. So let us see how many corner points are there. There are 3 corner points till now. A is your 0, 2. B is your 3 by 2, 1 by 2. Okay. And your third one, C, is your 3, 0. Okay. These are the corner points from where the graph is or shaded portion is starting. Okay. So this is A 0, 2, B is 3 by 2, 1 by 2, and C is your 3, 0. So using corner point methods, corresponding your objective function is 3x plus 5y. So these are the corner points. Let us check at 0 to z coming out to be 10. At 3 by 2 and half, put it here. You will get it as 9 by 2 plus 5 by 2, that gives you 14 by 2, that is 7. And for 3, 0, z is equal to 9. So we were supposed to find the minimum value. So the minimum value is coming at this point. Z is minimum. But see, this is not a bounded curve. In bounded curve, if it would have been a bounded curve, we would have been finished up to here that your 7 is the minimum value. Since the curve is unbounded, so remember theorem number 2, the second portion where we discussed the condition for unbounded portion. Okay. So let us see how we work out for it. Now I have to confirm whether 7 is the only minimum value and no other minimum is occurring. So for it, what we need to do is, as feasible region is unbounded, therefore 7 may or may not be your minimum value of z. Okay. To confirm it, what we need to do is, we need to draw the graph of inequality 3x plus 5y. 3x plus 5y means your objective function. We need to check whether any other value is there which is less than 7 or not. Okay, in case of greater than, if it is maximum, then you have to check greater than 7. Okay, but since here it is the minimum value we are talking about, I should check any other minimum value is there of this objective function which is less than 7. Okay, so we need to plot the graph of inequality 3x plus 5 y less than 7 and check whether the resulting half plane has point in common with feasible region or not. Okay, that means if it has a point lying common, this plotting having any line any point common with the feasible region or not. Okay, so let us see. For it again I need to consider the equation. So corresponding equation is 3x plus 5y equal to 7. So y is your 7 minus 3x by 5. I just need to get the value so that I can check where it is touching x and y. So x0, y is turning out to be 7 by 5, that can you be calculated as 1.4, and this is your 0, so it is 2.3. Let us plot. As it is strict, see the inequation is strict less than, so it will be a dotted line. So see, this dotted line has been plotted here. Here it is, I have taken 1.4. Okay, this your 2.3 comma 0 and 1.0 comma 1.4. Okay, so this is your plotted line. Now see, feasible region is starting from here. See, this line has any common portion with this feasible region or not? No, this line is going side by side. It is not falling in the feasible region. No point is there which is common with this feasible region, and this is the only condition for confirming that this 7 is the only minimum value. If the point is, some point is common with this feasible region, then in that case no minimum exists or no maximum exists. Okay, that means this line, when we will plot this objective function line, it should not have anything common with this feasible region. Okay, so is happening in this question, nothing is common with this feasible region. So that means what is concluded? We find feasible region has no point common with 3x plus 5y less than 7. So therefore minimum value z is equal to 7, and it is lying at x is equal to 3 by 2 and y is equal to 1 by 2. Thank you very much.